Hey guys, welcome back to 3 Inquisitive Kids. Today we're going to be looking at a geometry problem that is about AMC 8 or math counts level, so for middle school students, and this is competition math. So we're going to be using some concepts that we've learned from the AMC 8 course to solve this problem. So if you're interested, be sure to check out the AMC 8 playlist on our channel after this. Anyway, so here is the problem, and I want you to first pause the video to see if you can solve this on your own. Okay, so let's come back together. Square ABCD with a side length of 6 is arranged as follows, with 2 equilateral triangles as shown. What is the area of triangle EDF? So let's first analyze what we have here. We know that this is a square, so obviously here we're going to have 6 as well, 6 and 6, and they're equilateral, so all of these sides are 6. So we know that basically all of these sides here are 6. And we know that we're trying to find the area of this shaded region, this triangle over here. So let's work backwards. So our first step is to work backwards. So where do we start with this problem? Well, as you can see here, we have an obtuse triangle. And we're trying to find the area of a triangle. So in order to find the area of a triangle, we need 2 things. We need the base and the height. So, do we already know one of its parameters? Well, we already know one of its side lengths is 6. So, all we have to do now is find its corresponding height. So, if we just extended this over here, we'll see that if we made a point that's 90 degrees, then we're going to know, and if we found out, let's call this, say, point O, then if we found OF, then this would be the height. So, let's try to find the height, or the length of the segment FO. Well, as you can see, as I was connecting D to O, or extending ED, you'll see that I have already drawn the height of one of the equilateral triangles here. Here we have an equilateral triangle, and this is exactly DO is one of its heights. But because it is an equilateral triangle, which is a type of isosceles triangle, we already know one of the properties of isosceles triangles. In an isosceles triangle, whenever we have a line from the vertex straight down the middle, that is the height, right? That is the height. But at the same time, it is the midline because it splits its opposite side into equal halves, and it is the angle bisector. So this is an important feature of isosceles triangles, that its height, angle bisector, and midline are all the same line, which means that we have the properties about this triangle as well. These 2 parts are the same, so CO is equal to FO, and these are the same angle. And because it is an equilateral triangle, we know that both of these are 30 degrees. If both of these are 30 degrees, then it means that this is 60 degrees. We know that because the side length of FC is 6, and FO is exactly 1/2 of FC, then we know that this part is 3. So we know that the height of this triangle EDF is 3. So if we multiply 3 to 6 to 1/2, we have 9. So 9 is the final answer to the problem.